Hello, wonderful students. All right, today what we're going to talk about is our notes packet where we're going to look at the symbols, the notation, the properties, postulates, theorems, all that kind of good stuff. All right, so first thing we're going to look at is the first page, the symbols and notation. All right, now I already have these filled out from years past, so I'm going to go ahead and just kind of explain it. That way you're not waiting for me to write things down and draw the pictures out. You can pause the video if you need to slow down a little bit, okay? All right, so the first part that we're gonna look at is our equations, right? Our equality. So hopefully you know the equal sign. I think we've learned that multiple times. And what it means is the left side and the right side of your equation are equal. So 3 plus 2 is 5, 4 plus 1 is also 5. They might look different, but both sides are going to be equal to each other. The next one is congruent. The congruence symbol, we use this one all the time. Congruent means that we're not looking for numbers that are equal, but we're looking for just in general the shapes or line segments or angles or whatever it is to be equal to each other, to be congruent. So this line segment AB and line segment CD are considered congruent if they have the same angle, or sorry, not same angle, the same distance from A to D as it is from C to D. All right, and I try to make those two lines so that they have the same length on them. And here's how you write line segments. Line segment AB is congruent to line segment CD. And we'll start talking more in this unit about the order of how you do these, especially with proofs. You have to make sure that you are going in the same order from the first line segment to the second line segment. All right, I'll explain more about that later. All right, next one is similar. All right, so the symbol for similar is just one of these squiggly lines. It's a tilde in Spanish. It's a, what is it? It's above the tab button on your keyboard, okay? And it means similar. So these two triangles here are not equal, right? This little triangle over here, triangle EFG, is not equal. It's not the same size as my triangle HJI, but they are similar because they're going to have some of the same properties to them. Similarity means that they are going to be proportional to each other. That means that one of them is a larger, like an enlarged version of the other one, all right? Or you can think of like a reduction, like a smaller version of the other one, okay? And then approximately is when you have two of them. So similar is just one squiggly, and then two squigglies is approximately. So like this decimal here, if I wanted to approximate that number, I would say approximately 2.4. We talked about that in Unit 1 a lot when we had decimals. Okay. Not equal to, it's an equal sign with the line in it, so it means not equal to. So 0 minus 7 is not equal to 10 minus 84. Right? Those two are not going to be equal values. And we can use not equal for angle measures. We can use them for side lengths, anything like that. Parallel, this one's kind of a hard one to see. Sorry about that. It looks like this. It has the lines that are parallel. They can either be vertical parallel lines or they can be like slash side-to-side lines. I like to do mine like this one. So parallel means that they're never going to intersect. This says never intersect. And they have the same slope. And remember, we mark parallel with that extra little arrow in between. I can zoom in just a little bit on that. Okay, with that extra little arrow to show that they're actually parallel to each other, that they have the same slope. Okay. All right. Oops, I scroll just a little bit bigger. There we go. All right, keep going. Perpendicular, here's the symbol for perpendicular. It looks like an upside down T, right? And it means that we're going to intersect at 90-degree angles and that we have opposite reciprocal slopes. So not just opposite in sign, but also fractions flipped upside down. That's where the reciprocal part comes from with their slopes. And we've talked a little bit about parallel and perpendicular in that first unit, right? Remember when we have right angles, then we have perpendicular lines, okay? And then this is the symbol. This is the symbol and the notation for a line, all right? So a line that goes through A and B means that it's going to go on forever and ever and ever after it hits A and after it hits B on the left and the right. So the symbol needs to have the arrows on the above the letters A and B. And you can write them backwards. You can call it BA and AB, line AB or line BA. It doesn't matter whether you start on the left and go to the right or whether you start on the right and go to the left. All right, that one doesn't matter. A segment, I already kind of showed you up here with the congruent symbol. So segment, it does not have any arrows. You might see them with the little dots on them, but you don't need that. Typically, segment is just a line. So this means that it's going to stop at A and it's going to stop at B. We're only looking for that little part right there. And then ray AB looks like this. So see how it starts at A, right? The dot starts at A and the arrow goes through B. This line goes through B and that's going to continue on after I hit B. So this is called a ray AB. It's going to have a starting point, then it's going to go on forever. And I purposely went to the left because everybody thinks that rays cannot go to the left. But the arrow, the notation on ray AB has to go to the right. Okay, so it doesn't go to the left just because that line goes to the left. All right. And then angle, remember we've got two different ways that you can draw out the symbol for angle. You can either do kind of the less than symbol, or you can do my one that has the arc inside of it. But it means an angle where the middle letter, remember when we write out the angle, the middle letter is the vertex. And you could say angle FWQ, or you can say angle QWF. You can go backwards. This is just one example of what that looks like. Okay. For a triangle, we use the symbol for triangle. It looks like this. And then my triangle, it can be any type of triangle. It can be equilateral. It can be isosceles. It can be scalene. It can be a right triangle. It can be an obtuse triangle. It can be an acute triangle. It doesn't matter. Okay. Equiangular triangle. And we write it like this. We say triangle, and then you just start at one of the points. And I like to do it in order. So I did SKY, so it spells out a word. All right, but you don't have to do that. You could do it in any order you want. You could start at Y and go YKS. You could start at S and go SYK. But don't write the starting letter. Don't write that twice. Okay. And then a parallelogram. We all know what a parallelogram looks like. I have some students that actually do the symbol for parallelogram, and that's fine. That one's the easiest one to draw. You can also just put MATH, and we know that it's a quadrilateral. All right, so MATH, it needs to go in order. It cannot jump across letters. It can't go from M to T, and it can't jump from A to H. All right, so it has to go in order around, but once again, the order doesn't really matter. Okay, and now circle, right? This is a symbol for circle. So it's like, it looks like the target symbol. So like a circle with a dot in the center of it. It has to have the center because the center is how we name the circle. So we do the symbol for circle C, and I call it circle C because C is the point that is the center of that circle. Okay, it's the point at the center of the circle. So it could be circle A, it could be circle R, it doesn't matter as long as it has the center in it. And then the last one, the last symbol that a notation we're going to talk about is the therefore symbol. So when you're saying something like you're looking at a triangle and you say triangle ABC is therefore a right isosceles triangle, it usually means that you're proving something. So like you're showing me like, oh yeah, it had a right angle, had two perpendicular lines that made a right angle. And then you said, oh yeah, and two of the sides were equal. Remember when we did the quadrilaterals and the figures in the coordinate plane, we had to justify how we knew it was a right isosceles triangle. We could have used the therefore symbol to say, all right, well, now that I've done all this work, therefore, or triangle ABC is therefore a right isosceles triangle. All right, that's kind of a cool symbol if you ever can use that like in a real life situation. Okay, you can also use these symbols in other respects as well. Like science uses the therefore symbol, you know, because they do a lot of math parts too. All right, got any questions on those? Let me know. Okay, you can rewind and watch again. Let's flip to the next page. flip to the next page, properties. What are the laws that we need to know? So property is going to be on the left and the description is going to be on the right, okay? So the first one is the reflexive property of equality. All right, so reflexive, this is one that we're going to use all the time. And I always have students as we get started on this, they're like, what do you mean reflexive? How do you not know that A equals A, right? And that 7 equals 7, and that 3 plus 2 equals 5, and 5 equals 5, right? So reflexive property is basically telling me that we're going to have two parts that are the same thing. This is going to make sense when we actually get to our inequalities, or not, sorry, woo, I just went to algebra 1, not inequalities, when we get to our proofs. All right, this is going to make more sense. Here's the reflexive property of congruence. So if I look at this figure here, this, let's say it's a square or a rectangle, whatever, and I draw the diagonal across, the line segment AB is the same line segment in that top left triangle as it is in the bottom right triangle. So that's why we need the reflexive property, because that line segment can be two different lines in each triangle, but it's actually the same line. Okay, so, and we'll talk about how that notation works, about like, how do we write that every time? You can have angles that are congruent to each other, like angle A is congruent to angle A, because it's in each of those triangles, okay? So we'll talk more about that, but just know that that's a property that we're gonna talk a lot about. Symmetric property of equality. So here's the property. I'm gonna zoom in because that's, once again, really hard to see. Sorry about yellow. So the symmetric property of equality says if A equals B, then B equals A, right? Symmetric, like looking in a mirror. When I have my hair crazy, I look in the mirror, my hair is crazy in the mirror, right? A is equal to B, B is also equal to A. What I see in the mirror is equal to what my hair looks like, right? If I don't know, if I can't see that. So I think about this in terms of like fractions to decimals. So 1/2 is equal to 0.5. They're the same thing, but they might be represented differently, right? One fraction, one decimal. And then it also goes the other way. Well, if 1/2 is equal to 0.5, then 0.5 is equal to 1/2. They're equal to each other. They're the same thing. So symmetric means that we reverse them, right? You see how they're reversed? Fraction equals decimal, decimal equals fraction. That's what the symmetric property looks like. Now, in congruence, in our proofs, what this might look like is if, so symmetric property of congruence, if this line segment here is congruent to this line segment, then that means that this line segment is congruent to that line segment. Once again, different representations, but if they're congruent, then I can flip them forwards or backwards. AB is congruent to CD, CD is congruent to AB, those line segments. Okay. I personally love the transitive property. It's one of my favorites. The transitive property says, of equality, says that if A equals B and A equals C, then B equals C. So here's the way that I think of this. So if my birthday is December 22nd, right? That's the day, right? December 22nd equals my birthday, my B, right? If December 22nd is my brother's birthday, I don't have a brother, so we obviously don't have the same birthday, but let's say that he had the same birthday as me, then what can I assume? That he and I have the same birthday, right? December 22nd is my birthday. December 22nd is my brother's birthday. Therefore, my brother and I have the same birthday, right? We're just kind of cutting out the middleman is the way I think of this. We're just cutting out A. We're saying, why is A even important? I don't need to tell somebody else that, oh, my birthday is December 22nd. Oh, guess what? My brother's birthday is December 22nd. I would cut that out and I would just say, hey, my brother and I have the same birthday. All right. So for congruence, the transitive property of congruence says that if I have angle X and it's congruent to angle Y, and angle X is also congruent to angle W, Well, what do I know? I know that y and w, angle y and angle w, are also congruent, right? If angle x is 10 degrees and angle y is congruent to that, then it's also 10 degrees. If x is 10 degrees and w is also 10 degrees, because that means congruent, then y and w are both 10 degrees. So some of these seem pretty redundant. You're like, why does this even matter? When we get into the proofs, you're going to see where these properties are necessary. Okay, I promise you'll see it. You don't see it right now. Okay. All right, the next one is distributive property. And we love distributive property. Hopefully you remember what that looks like. You're going to take the A and you're going to distribute it inside the parentheses by multiplication. So A times B plus A times C. We don't have a congruence property for distributive property, but I just wanted to remind you that that is a property that we use. So know that it can come up anytime. Same thing with substitution. So a quantity can be substituted for its equal. So if I say I don't have any dollars with me right now, but I know I owe you, $3. Can I substitute the dollars for quarters? I've got quarters with me. I don't know why I would have quarters, but anyway, that's the idea here. So to substitute something that is its equal. So $3 worth of quarters is the same as $3 bills. All right, and then the last one on this page is the addition, subtraction, multiplication, and division properties of equality, meaning that we're taking adding, subtracting, multiplying, or dividing both sides of an equation by the same thing. So we can justify why we solve an equation the way we do by doing the opposite, undoing the addition property of equality, undoing the multiplication property of equality, all that. Okay, these are things that you've learned in 8th grade or 7th. I don't know which grade, but anyway, they have been there, I promise you. Okay, a couple more, and then I'm gonna stop and I'm going to do a separate video. Okay, I'm just gonna do a few more of these. Excuse me. All right, so postulates are things we accept as true. So remember when I told you we were going to talk a lot about postulates and theorems? This first one is postulates. So what we're actually looking for is we're looking for things that we don't have to prove. Things that we just say, oh, well, yeah, that works because there's no other way to do that. Okay, so here's the first one. This segment addition postulate. Okay, segment addition. So think about that. We're taking two segments and we're going to add them together. So what does that mean then? Okay, so here's what it means in like symbols. So the measure, that M means measure of angle of line segment AC. So this big long line segment from A to C, that is equal to this measure, this distance from A to B, plus the measure from B to C, right? So think about that. These two pieces plus these two pieces equal the entire line segment, right? That's kind of a duh, right? I don't need to prove that to somebody. I can. If this is 3 units right here and this is 10 units, then the whole thing together is 13 units. That's just math. That's something that we accept as true, right? Nobody had to prove that to us. We discovered that that's how that works, and we gave it a name. We gave it the segment addition postulate name. All right, then we can also do this with angles. So the angle addition postulate is the same idea. So remember, M means measure. That should have been a lowercase m. Sorry about that, little typo. But anyway, so that M in front of the angle symbol means measure, right? So we're talking about the degrees this time, not unit, not inches, centimeters, anything like that. We're talking about degrees. So the measure of angle AXC, so A down here to X and then to C. So that's the big angle. That's all the way across all of these angles, the big one, equals the measure of angle AXB. So this one here, the one that I marked with just a single curve, the single arc, plus the measure of angle BXC. This one right here, this little angle right here. So if I take both of those little angles and I add them together, then my angle addition postulate says that I'm going to find the measure of the big angle. Once again, duh, that's math, right? You take, let's say this is 20 degrees and then this one over here is 5 degrees. If I take 20 and 5 and I add them together, I get 25 degrees for the big angle, the two of them combined. Okay. All right, then we get into a little bit of parallel and perpendicular. So parallel comes first. So parallel lines, what do we know about parallel lines? Well, non-vertical lines, non-vertical, right, not up and down, non-vertical lines are parallel if and only if. That's a phrase that you're gonna have to get used to. If and only if stands for, it's a forwards and a backwards relationship. All right, I'll explain that in a second. If and only if they have the same slope. So what that means is, if I say that something is parallel, then that means it has to have the same slope. That's what if and only if means. It also goes backwards though. If I see two lines and they have the same slope, I can automatically say that they are parallel. So parallel and same slope are forwards and backwards relationships with each other. All right, and the vertical lines are always parallel to each other, and that's because they have the same slopes also. All right, so here's how we write this. So if I'm looking at these two lines here, we usually name them with just L and M, but you can also write them out as line L and line M. And so the symbol for parallel is this symbol right here. And so I say L is parallel to M, or you can say line L is parallel to line M. So the symbol for parallel is like these little arrows here, or you can use the parallel sign, like over here on the left side. Okay, so they have the same slopes. Then perpendicular lines, right? These oops, where am I at? There I am. My perpendicular lines are non-vertical lines, are perpendicular if and only if, there's that phrase again. I didn't mark it, but I should have. Their slopes are negative reciprocals. Negative, I call them opposite reciprocals. That's just my preference. That's how I learned them. So opposite reciprocals are never negative reciprocals. So if you have two lines that you say, these two lines are perpendicular, then I know for a fact that their slopes have to be opposite reciprocals. If I tell you that I have two slopes that are opposite reciprocals, then you know that they're perpendicular. It's a forwards and backwards relationship. All right, and a vertical line is perpendicular to a horizontal line. So I drew an example here. And we know that because we make a 90-degree angle. A zero slope, which is a vertical line, or sorry, an undefined slope, which is a vertical line, and a horizontal line has a zero slope. When those two meet, it means they meet at a 90-degree angle, which is perpendicular. Okay, so there's an example of what that would look like. So line AB and line ZY, can't get that word right, they're perpendicular to each other. So this is how you would read it. Okay. All right, let me see what comes next. All right, I'm going to take a break and stop my video, and then I'll restart and finish these. Okay.